Yeah, we shall start. So from number 91, it says consider the reaction below. So we have that reaction over there. And then it's asking what is X most likely to be. So X. So we have yeah, watu wa chemistry wachangamke tafadhali. So we have an alkene there reacting with 2 molecules of bromine. So what's the product? So there's someone saying A. So should someone take us through these types of reactions like the substitution and the rest? Watu wa chemistry wenye wanajua. The types of reactions in organic chemistry. Anyone? Or is everyone agreeing with choice A, that the answer is 1,2-dibromopropane? Someone has inboxed me saying that we'll continue, and then she's is going to give us a brief summary of the types of reactions in organic chemistry. So maybe you can go to question number 92. As when they are ready, they'll share the screen and present. So number 92, kindly letting, if you can scroll up. Dr. Letting. We were saying, yeah, so we were saying number 91, Comfort. Do you have anything to share? I've seen that you've texted in the group. Are you in a position to share? No response. Yeah, she's saying no. Not share the screen, like to share the like your input about number 91.
Why not D?
Yeah, there are two choices, one and like A and D. So that's why I'm saying for those who are saying it's choice A or D, they should explain. Anyone? I may go to number 92 as we wait for. Okay.
I also think it's D. I have seen, trying to see, because there's a document I'm using here to see it's kind, because you can see the reactant, the 3-bromo-1-propene reacting with 2 molecules of bromine. So the final product is going to have 3 bromine. So it will be that 1, 2, 3. Sorry, I can't see the screen so nicely. I'm trying to zoom. But 1, 2, 3 tribromopane. Yeah. If you okay, I like to break it down to expand the molecule so that you'll see this double bond is the one which will open up, and then the 2 bromine molecules will attach to this carbon. I'm doing it on a paper and I'm assuming. But yeah, so that double in the final product, you won't have the double bond, and the bromine molecules will be in the final product. So it will be 1, 2, 3 tribromopropane. I believe the answer should be D. Yeah.
Yeah, the answer should be D. If it were hydrogen bromide, then the answer would have been A, because according to Markovnikov's rule now, the hydrogen goes to the carbon with the most hydrogen atoms. So if it were hydrogen bromide, the other one, the hydrogen would have gone to the last carbon, and then bromine to the second one. That's why we would have like 1, 2 bromopropane. That would have been the answer. But then since it's 2 bromines, then we'll have now 3 bromines across. I hope I'm clear.
I think I can. The last thing I can add, I'm going to send a document to the group. This reaction is an addition reaction. So it's saying an addition reaction occurs when 2 or more reactants combined form a product without the loss of any atoms present in the reactant. So it's common in compounds that have unsaturated carbon bonds, for example, the double bonds and the triple bonds. So the weaker pi bond is converted into 2 new stronger sigma bonds, which is what has happened in this reaction. Like once that double bond is what has now broken the weaker pi bond and formed 2 new sigma bonds, hence the resultant product 1, 2, 3 tribromopane. So that's an addition reaction. The other common reactions are elimination reaction, substitution reactions, and there's also radical reactions. That's from this website that I'm reading from. It's the same website that I sent the picture that is on the group. So I'll just send the link. It has been summarized quite well, so you can be able to see the different types of reactions there. Yeah.
Thanks so much for that input. So you've seen the correct answer is D. So number 92. Kindly move up kidogo letting. Thank you. So which which one of the listed products will be the most probable from the following reaction? So again, organic chem are the experts in organic chemistry. So you have that molecule in the presence of phosphoric acid that is acting as a catalyst, and potassium iodide. So the product that is going to form from that reaction. Anyone? Spider-Man, unmute bana.
Organic chem tuliachia Sonia.
So
It should be A.
Yeah, it should just be A. It's I think it's similar to the previous one because there's an unsaturated, you can see a double bond cyclohexene, and then we can see potassium iodide. If it was now like I to 2 molecules of iodine, then we would have had what is probably in B. But because it's potassium iodide and H3PO4 is just the catalyst, it's just helping the reaction to occur. A is will break the pi bond and form a sigma bond with the iodine. So I believe it's A. The answer is A, I think.
yeah. So we continue to suffer in organic chemistry. Number 93. What is product Y in the anti-Markovnikov addition of below? Anyone who is able to take us through this addition reaction? Organic chemistry gurus. Divya, it's your moment to shine.
I think it's C. Yeah, it's C.
Kindly explain.
It's still an addition reaction. It's actually the exact same. If you look at this one and the previous one and the other one, they're like they're the exact same. If the principle is the same, where the double bond is, it's an addition reaction, so it's hydrogen bromide. So that double bond will break. Sometimes, like I said, it might be difficult to see when the formula is compressed like that. So if you like have a paper and you just draw it out, you'll be able to see where the double bond breaks and the bromine is added. So if you stretch out C, you'll see that double bond has broken and you've put bromine on carbon number 2. And yeah, the molecule is just complete. So that's just how addition reactions work. The double bond or the triple bond, they just work on those unsaturated bonds. It breaks and it forms. You add the molecule to the reactant to form your new product. So it's the exact same principle as the last two questions, and you'll get C.
But is it
Question, Sonia.
anti-Markovnikov like different from Markovnikov?
Oh, the question is saying anti-Markov. Sorry, I didn't
Yeah.
read that. I didn't
I
read
think
that.
because for Markovnikov, then the hydrogen would go to the carbon with the more hydrogen atoms. That's the last
Yes.
one. Yeah,
Yeah.
but now the opposite. Or maybe B.
B, the bromine is on the last. The carbon, yeah. Carbon 1, 2. So HHBr.
But Sonia,
Yes.
I have a question. See, anti-Markovnikov is not that the substituent is replaced on the carbon which has the least substitutes.
I think
Or
that's what now we are correcting, because me, I had not, I had
Oh.
not read the question. I had not seen anti-Markovnikov addition. Yeah.
Okay.
Yeah. Based on that, I've drawn the structure. I'm also finding it's boy.
Yes.
So C would be for Markovnikov.
Yeah.
Okay. So number 94. Which one of the following is not true about ethers and alcohols of similar molecular weights? So you have choice A, ethers have lower boiling points. Choice B, alcohols generally have lower melting point temperatures. Alcohols are better hydrogen donors. Ethers are generally less reactive. So among those statements, which one is the false one? You can type in your choices in the chat box. Yeah. So what are your thoughts about it? Sorry?
I'm thinking choice B, because alcohols, because of that potential for hydrogen bonding, generally they will have a higher boiling point and a higher melting. So I'm thinking choice B.
So anyone with a different answer? Am I all agree with choice B? And so we can go to number 95, but which products will be the most stable in the bromination of Divi is saying the other answers are true in the chat box. So yeah, so just be so number 95, which product will be the most stable in the bromination of nitrobenzene? So we have ortho-bromonitrobenzene, meta-bromonitrobenzene, para-bromonitrobenzene, ortho-para-nitrobenzene. The product that is going to be most stable when you react. So Spiderman is saying ortho-para-dinitrobenzene. So is everyone in agreement with orthoparadinitrobenzene for number 90?
I think nitro group is a meta directing group.
Yeah, so yeah. So you're saying B. So most people are going for B. Sorry. So as we have heard, it will favor the meta direction in that reaction. So the most stable compound from bromination of nitrobenzene will form meta-bromonitrobenzene. So number 96, which of the following statement regarding agonists is not true? So choice A, receptor binding triggers a response. Choice B, are structurally similar to endogenous body chemicals. Choice C, lack affinity for the receptor site. Choice D, they tend to be highly specific. So I think this was covered during this week or last week. Gas, I think you covered this. The agonists.
Yeah. Yeah.
So people should be able to come up with answers for those who attended and for those who listened. Sorry?
I think it's that choice C that is not true. They do have affinity for the receptor site.
Yeah. So for 96, it's saying that lack affinity for the receptor site, that one is not true about the agonist. So number 97, which of the following statements regarding physiological antagonism is true? So choice A says the two antagonists compete for the same receptors. It is of no clinical importance. It is usually irreversible. And choice D, the antagonists are not structurally similar. So the statement that is not true regarding physiological antagonism, the statement that is true, sorry, about physiological antagonism. So we have Dr. Shafi and Spider-Man flying with the choice D, saying that the antagonists are not structurally similar.
Oh, Stanley. Okay. Wanted to add on the physiological antagonist. Like there are two different substances that antagonize, that produce different physiological effects in the body. So if this one is raising the blood, just an example, and if this one is raising the blood pressure, the other one is lowering it, for example. So they don't compete for the same receptors, but the receptors are usually like close to each other. So, but they counteract each other's action like through different mechanisms. So that will cause antagonistic effect. So yeah, the antagonists are not structurally similar, unlike agonists. I don't know if that makes sense.
Thank you so much, Dr. Nugal, for that add-on. If you have anything to add on any of the questions, kindly feel free to add on. Yeah. So number 98, which is I think it's a framework for everyone. So a competitive antagonist says that has affinity but lacks intrinsic activity. Choice B binds irreversibly to a receptor. Choice C reduces the maximal response of the dose curve of the dose response curve. Choice D causes a left shift of the dose response curve. That one should be mteremko for everyone. I should be expecting answers flocking in the group chat. Guys, Nugal.
Hey, what's up?
I was asking if you could take us through like just the basics of this agonist and antagonist, just basics, like for 2 minutes, as a recap of what you guys covered last week. Are you in a
Okay.
position to do that?
Yeah.
Yes,
So agonist and antagonist, we know agonist will mimic the action of the endogenous ligand that it's built upon. For example, salbutamol will mimic the action of noradrenaline, or rather of adrenaline, on the beta-2 receptor. So we say salbutamol is a beta-2 agonist because it mimics the action of the normal or of the physiological endogenous ligand. Then antagonist, for antagonists now, these ones, they will bind to the receptor and inhibit binding of the endogenous ligand. That is why we will say antagonists have no intrinsic activity, because intrinsic activity simply, here we are talking about eliciting a response once it has binded to the receptor. We know once salbutamol binds to the beta-2 receptor, it will elicit a response. This response is bronchodilation. But once a beta blocker such as metoprolol binds to the beta-1 receptor in the heart, it does not elicit a certain activity. All it does is that it inhibits binding of the endogenous ligand. That's why something common to antagonists is we'll say they have affinity, but they have no intrinsic activity. They just block. They're just there to block the binding of the endogenous ligand. So agonists, they have both intrinsic activity and affinity for the receptor. Antagonists just have affinity of the receptor, but they do not have intrinsic activity. So when we go to, let me start with antagonist, which is kind of the main one, because agonist is that straightforward. Antagonist, we have 4 types of antagonists when it comes to drugs. We have the pharmacologic ones. Pharmacologic one simply means that drug A and drug B will bind to the receptor and elicit different responses. A good example is propranolol, which is a beta blocker, and norepinephrine. They bind to the same beta receptor but elicit different responses. The second type of antagonism is the chemical antagonism. This one is as simple as that. There's a chemical reaction. Acid plus base is equals to salt plus water. I have acidity, you give me Gaviscon, and that is it. Simple as that, a neutralizing reaction. It's based on a chemical reaction. The third one is the pharmacokinetic antagonism. Pharmacokinetic antagonism, here we are talking about the 4 aspects of pharmacokinetics: absorption, distribution, metabolism, excretion. If a drug such as, let's say we say if you've overdosed on a weak acid, we usually want to give you a base, right? So that the drug can be excreted or eliminated in urine in high amounts. That's a pharmacokinetic antagonism. But we are having drug A antagonize or go against the action of drug B by altering one of the 4 parameters of pharmacokinetics, either absorption, distribution, metabolism, or elimination. The 4th one, my respected senior has already talked about it, the physiologic antagonism, whereby we are having both drugs or both hormones, both ligands binding to the same receptor, but eliciting a different action, right? Just to take you back to pharmacologic, is that, physiologic, we're having 2 drugs or 2 hormones binding to different receptors and eliciting 2 different actions. To take you back to pharmacologic, is that we were binding to 1 receptor, but eliciting 2 different actions. 1 receptor, 2 actions. That is pharmacology. Remember, beta blocker and adrenaline. That is pharmacology. But when you go to physiology, 2 receptors, 2 different functions. Good example is, again, for asthma, adrenaline will bind to the beta 2 receptor and cause bronchodilation. Histamine, on the other hand, will bind to histaminergic receptors and cause bronchoconstriction. That is physiologic. We're having drug A or hormone A binding to receptor A, and then drug B or hormone B binding to receptor B, and eliciting 2 opposing actions. Then the last part is about competitive, or rather that competition, which was covered, I believe this is the 4th time we're talking about it. Competitive inhibitors or competitive antagonists, right? Here we are talking about drug, they are competing for the same receptor, they both have affinity, but they are both antagonists, so yeah, competitive. And then non-competitive and competitive, non-competitive, uncompetitive, and suicidal. We've talked about that time and time again, so please allow me not to go there again. Finally, we have the partial agonist or antagonist. These ones, just remind a way to remember them is that they are simply attention seekers. That when the agonist is there, they will behave like an antagonist, right? When the agonist is there. So let's say when the adrenaline is there, this partial agonist will behave like a beta blocker, right? It's an attention seeker. But when the agonist is not there, this partial agonist will behave like the agonist. So back to the analogy. When the agonist is there, let's make a random name for a drug. Let's call it H137, right? Let's say that is the drug, H137. That is let's say H137 is a partial agonist stroke antagonist of the beta receptor. So when adrenaline is there, when the agonist is there, H137 will want to behave like an antagonist. But then when the agonist is not there, when adrenaline is not there, now it will want to behave like an agonist. It will want to behave like adrenaline. But when adrenaline is there, it wants to behave like a beta blocker. It's simply an attention seeker. It has to do something. Yeah. Then inverse, the other one, the last one is the inverse agonist. Simply this one will bind to the receptor, but elicit a different, or rather the opposite action. So an inverse agonist has both intrinsic activity and affinity. It will bind to the receptor and elicit different action. I think that's it, Stanley.
Thank you for that summary. Oh, sir. So they have been answered. So Divya also says a competitive antagonist binds to the same site as the agonist but does not activate it, thus blocks the agonist function. Also, she goes ahead to say they are different from agonists as they cannot trigger the stimulus that leads to biological responses, that is, they lack intrinsic activity. So she was trying to answer also number 98. So number 98, as I was saying, competitive antagonist has affinity but lacks intrinsic activity. That one has been said. Also, number 99 has been already answered from the brief summary. Neutralization of gastric acid by sodium bicarbonate is an example of chemical antagonism. So number 100, 100. So which of the following are routes of drug administration is least likely to result in systemic absorption? So you have the sublingual, inhalational, oral, and topical. So the answer there should be D, topical. Yes, it's straightforward, I guess. But if anyone has a different opinion, you can say. So number 102, vitamin B12 is absorbed through. So we have endocytosis, active transport, passive diffusion, reverse osmosis. So vitamin B12 is saying that is being absorbed through endocytosis. Yeah. So what is the other name of vitamin B12? Anyone? So Div is saying absorbed through the distal ileum through receptor cell mediated endocytosis. So the other name of vitamin B12 is cobalamin. So we also have vitamin B6, which is pyridoxine. The other name for niacin, which niacin is vitamin B what? Niacin and folate. So niacin is B3 and folate. Folate is B9 and riboflavin. Riboflavin. Yeah. So riboflavin is vitamin B2. So I think should also be able to know that. So someone is asking vitamin B1. It's thiamine. Vitamin B1 is thiamine. So we go to 102. Which one of the following does not promote penetration through the BBB? So you have the small particle size, inflamed meninges, high lipophilicity, and then you have the low molecular weight. So the one that does not promote penetration through the BBB. Which one does not promote penetration through the BBB? So someone is saying small particle size. What are the factors that promote penetration through the BBB? Anyone who can share? Spiderman was saying maybe in the group chat that small particle size does not promote penetration. Another one is saying
Yeah, I don't think small particle size promotes
yeah,
penetration, because particle size, when we're mentioning particle size, it's more of when we're talking about dissolution. This is when a drug is in the gastrointestinal tract. But after the gastrointestinal tract, the drug is in solution form. So when it's in solution form, then we mention about molecular weight. Stuff such as heparin, we say heparin can't cross the placental barrier because it's a high molecular weight. So based off that, that's why I'm thinking particle size, because molecular weight, we see it being implicated as a hindrance to cross the placental barrier. So I believe molecular weight then also can play a role in the crossing of this blood-brain barrier. But I stand corrected.
okay. Also there's choice B, maybe so there's something that has been sent in the group. The factors which promote the penetration across the PPB. So we have lipid solubility, we have molecular size. So smaller molecules can more easily pass through the BBB than larger molecules. We have the charge. So neutral molecules, or those with a slight positive charge, may have an easier time while crossing the BBB. While highly charged molecules are always repelled. So we have also active transport as another factor, which is saying that some molecules can use active transport mechanism to cross the BBB. For example, specific transporters facilitate the entry of essential nutrients like glucose and amino acids. So another factor, we have lipophilic analogs. So these are the designing drugs or compounds with lipophilic analogs can enhance the ability to penetrate the BBB. So from this, we've seen that particle size is one of the factors. Molecular size, small molecular, it's not the same thing as particle size. It's not the same, yeah. So choice B is saying that it's eliminated because the BBB is vulnerable due to meningitis. So it is eliminated. So I guess you can go with the small particle size because you've seen the molecular weight and also lipophilicity. Lipophilicity is it's one of the factors. So 103, which of the following is not a means of drug elimination? We have the renal secretion, binding to body tissues, fecal elimination, and drug metabolism. So you know that for sure renal is there, fecal is there. So I guess it's drug metabolism. Is metabolism why of sorry?
I was thinking B because if our drug is metabolized to, let's say, water, isn't that a way that the drug has been eliminated from the body? What do you think?
Yeah, elimination entails metabolism and excretion.
Yeah,
Yeah.
binding to tissues affects distribution, not it has nothing to do with elimination, I think. It's distribution.
The answer is B.
So sorry. Yeah, so I'll go with so binding to body tissues, as one of us has said, it's more of the distribution compared to elimination. So 104, drug metabolism may result in we have drug inactivation, decreased elimination through the kidney, drug activation, and production of toxic metabolites.
Drug activation.
So drug metabolism may result in drug activation.
Yeah, I feel like all our answers except.
Yeah.
They should have said except.
Yeah,
Oh, there's an
because
except.
No, they
I'm not
should be.
seeing excepts.
It should be there.
Yeah.
Because metabolism inactivate na bado some of the metabolites are toxic, so decrease elimination through the kidney. I don't know, maybe the question is a bit ambiguous ama sisi ndo hatujaelewa. What do you think? So do you think there should be an except ama
I
kina
think there
Seraphim?
should be an except.
There
Mi
should
nasema
be.
kunafaa kuwa na except because now for drugs that you want to be eliminated, then definitely you will increase, for most of them you will increase elimination to the kidney. Kama inakuja as a prodrug, then you need the metabolism to activate it. Ama kama you want it for excretion, you deactivate, then excrete some metabolites zitakuwa toxic. So mi bado nasema except.
But then also for phase 2 metabolism, acetylation increases lipophilicity, so that could also decrease elimination through the kidneys.
Haya, mambo yamechacha sasa.
Pardon, I didn't hear what she said.
She said that acetylation increases lipophilicity, and that can decrease elimination through the kidney. However, just on that, generally, like without looking at acetylation, perhaps, generally we say we metabolize drugs to make them more soluble so that we can excrete them. Like that's generally.
Okay.
Sawa. So that one you have. So what have you settled on with choice B? If the question has an except, senior.
If.
Yeah, if.
Yeah, but if it didn't have, I'd go with the inactivation as the best answer. If it didn't, if the question was just like this, I don't.
Yeah, I would also go for the drug inactivation.
Inactivation choice for choice A.
Yeah, because okay, I get that there are different drug metabolism effects, but what's the main major effect is drug inactivation so that the drug can be eliminated. The other ones are choices, but in this case, if there is no except, I say we go with drug inactivation because so that we can metabolize, like it's metabolized so that it can be removed. I don't know if that makes sense.
Okay.
But drug will not get inactivated unless you decrease its elimination through the kidney. That's also an answer. Decreased elimination through the kidney.
Haya. So this so 103. So someone is asking, when drugs are metabolized, does it decrease elimination?
Yeah, it decreases elimination
sometimes
because some
when-
drugs will be conjugated with and others will be like they will form the second metabolism. What do we call that? Majorly it increases.
Glucuronidation.
It does increase.
Glucuronidation.
Yeah.
Okay. Yeah.
But
So Dr.
Spider-Man is saying mostly it increases, but few drugs it decreases.
Okay, Dr. Anita has been answered. So we can go on to number 105. So responses other than the intended therapeutic ones are, so we have side effects, synergism, potentiation, additive effects. So that one is side effects, but maybe we can touch on what is synergism. Shafi, unajua direct hiyo. Shafi, tuambie synergism. Dr. Shafi?
Yes, umesema nini?
Synergism. From that, you know, the answer is side effects, but now we'll talk about like at least a few things about each of the choices.
Synergism say it's like combination of two drugs to get the best effect or the best therapeutic outcome.
Mm-hmm. So for 105 is A. So for potentiation, I would say it's when one drug does not elicit a response on its own, but enhances the response of another drug. So we have a drug A that does not elicit any response, but rather it's used to enhance a response of drug B. Sawa. So for additive effects, anyone on additive effects? Or Divya, we are in number 105. Sorry, yeah. Additive
Maybe to add
effects.
on your synergies, yeah, that one, synergistic effect. For example, we can give antibiotics such as like ampicillin when it's combined with sulbactam. So ampicillin is just a bacterial cell or inhibitor, right? And then the sulbactam now will inhibit the beta-lactamase inhibitor, making ampicillin more effective. So it adds to its action. We can use that as a synergistic side effect, I think.
Yes.
For synergism, the two effects are usually greater than the sum of the two drugs, like the sum of the effects of the two drugs, if that makes sense. And the additive effects, it's just the sum. But for synergism, the effect is usually greater than the sum.
And for the additive effects, I didn't get.
For additive effects, it's the sum of the two. Like you combine the two and just the sum. Yeah.
Okay.
Just a question.
Yes.
That example for ampicillin and sulbactam, that would be an example of synergism or potentiation. Because I'm just
thinking synergistic effect. That's why I was asking, can we use that as an example?
Oh, because I'm trying to see the difference between the two, difference between the synergism and the potentiation, because they're saying synergism is when the combined effect of two drugs is greater than the sum of their effects when given separately.
I think for potentiation is like when
Yeah.
you give, like when you have a headache, you take paracetamol to nini the headache, but then you get some paracetamol formulations comes with caffeine. So the caffeine helps with the whole increasing the absorption and the whole thingy. At the end of the day, it's like it increases the effectiveness of the paracetamol.
So that would be potentiation. That would
That
not
would be
be
potentiation. Like one of the drug on its own, it's not like it does much, but when you combine the two of them, they do more than one of. Okay,
so
sijui
like
nasema
aspirin
nini
and,
hapa.
like aspirin and caffeine. Like mara
Yes,
moja.
like aspirin,
Mara moja that has
kama
aspirin
aspirin na
and caffeine.
caffeine.
Yeah.
When you're given caffeine on its own for whatever pains you're having, it doesn't do much. It's like it doesn't even have an effect. Ni kama effect yake ni zero. But then when
Yeah.
you combine with either aspirin or paracetamol, it then increases the effect to even more of when it's on its own. Like the paracetamol or the aspirin. I think now that's potentiation.
Okay, and then the other example that Fatma had given would be an example for synergism.
Yes, I think that would be synergism.
Ampicillin
Yeah.
cell.
Mm.
All right, thank you.
You're welcome. So thank you for that. Thank you.
Yeah, but
So-
before we move to the next question, may I have a
So,
question on this one. What's the difference between side effects and adverse effects?
I think
I think
I think anyway, I think side effects are the ones which we can understand their pharmacological, like why they've come about pharmacologically, but then adverse effects are the ones which we cannot explain. Like, yeah. So I don't know how to explain. Like maybe the way.
Yeah, you're right, Willie. Side effect is adverse. It's like a type of effect that comes, and you can trace it back to pharmacologic way of the effect. And adverse effect is unwanted or harmful reaction that occurs. Yeah, expected. Or someone said side effect is expected and predicted effects of drug, and then adverse is unpredicted effect of a drug. Yeah.
Yeah. So for side effects, you can trace it back to the pharmacological activity. Let's say you take an example of aspirin, GI irritation, or NSAIDs. You can trace it, and then for the other one, the adverse effects, you can't trace back it to the pharmacological effect. Here, Seraphine, have you been answered?
Yeah, that's okay. Thanks, guys.
So tolerance is reduced response on prolonged use of drug associated mainly with single drug use due to sudden drug withdrawal associated with all types of drugs. So that one is tolerance is just obvious, reduced response on prolonged use of a drug. So we also have tachyphylaxis. Anyone who can define tachyphylaxis? Because they go hand in hand with tolerance, but there's a difference between tolerance and tachyphylaxis. Anyone who can define because tachyphylaxis. Nightwing.
Tolerance long term. Alafu naeke mtu anasema
Sorry?
Tolerance. It's long term desensitization.
And then tachyphylaxis?
It's acute.
Oh yeah. So it's rapid. So tolerance is developed over a long period of time, and then for for tachyphylaxis, it's a rapid one. So as you can also say, tachyphylaxis is an acute event, and then tolerance is a chronic. So legend is also saying reduce the effect of the drug, even if the dose is increased. So number 107, which one of the following drug is not a plant or is not of plant origin? So we have quinine, cotrimoxazole, atropine, and artemisinin. So that one is cotrimoxazole. So we'll also maybe mention the plant origin, like maybe quinine, where is it derived from? Atropine. So for choice D, I know it's the plant for anua. So atropine is
Atropine seeds, Atropa belladonna.
belladonna, yes. And then for quinine,
Cinchona.
Zinchona.
yeah. So 108, which of the following? Which of the following is true about a prodrug? So it is more active than the drug. It retards drug absorption. It is less stable than the drug. It is activated by enzymes. So I'll go with D. It is activated by enzyme. Anyone who is of a different opinion? So I guess we'll go with D. So 109. Which one of the following drugs has the longest delayed onset of action? So we have warfarin, adrenaline, acetylsalicylic acid, and pilocarpine. So someone is saying back to 108. Spider-Man is asking if we can mention common examples of prodrugs.
Prednisone is one of them.
Yes, the most common one actually. Another example of prodrugs. Sorry?
Levodopa. Yes,
I didn't get that, Pole.
is it? Can we say that? Oh no, let me.
Willy, are you?
Nimeangalia naona.
Oh. So another example, you also have azathioprine, which the active drug is mercaptopurine. Levodopa, which the active drug is dopamine. Yes.
How about aspirin? See, the active drug is salicylic acid.
Hey. Salicylic acid.
I don't know.
Yeah, it's converted to.
Yeah, that's why it's metabolized. That's why it causes the GI
Actually,
disturbances.
it's converted to salicylic acid in the stomach.
Yeah.
Oh. Hey, that's nice. Yeah, that's nice. Hey, thank you for that, Sal. So
Even enalapril.
enalapril. Yeah, it's inhibitor. So what's the active drug? The enalapril.
Enalapril. Something like that.
Enalaprilat.
Is morphine a prodrug?
Sorry?
Is morphine a prodrug?
Or is morphine a prodrug?
I don't think so. Yes, the glucuronide portion is, or metabolite is more active, but even morphine itself is active. Because I think for prodrug is when the drug you're giving has no effect. It has to be activated. Just my thoughts.
Yeah, I've done a search saying that morphine is not a prodrug. Yeah. So on that note, 109, which of the following drug has the longest delayed onset of action? We have an expert. Spiderman is an expert here. Yeah, warfarin. Could you kindly explain how long does it take for it to?
I think 72 hours, 3 days, or 2 to 3 days.
After administration?
Yeah, and the reason why it has delayed onset of action is because it doesn't act on already circulating coagulations. It's delayed because it interferes with the synthesis of clotting factors in the liver. It doesn't act immediately on the blood clot that's already there.
Okay.
I think also peer half-life phase of clotting factors long.
Sorry, Shai, but we have to just hear the half-life of the clotting factors.
Those clotting factors, yeah. Come on,
So
yeah, I think that's why also warfarin must be overlapped with the rapidly acting these coagulants, the parental ones such as heparin, like the fondaparinol. Yeah.
Yeah. So the tamoxifen. So 110. Idiosyncratic reactions are expected and extension of the drug action. Choice B, related to the pharmacological profile of a drug. Choice C is unusual and uncommon. Choice D, due to tolerance. So idiosyncratic reactions, what are they?
The dose-dependent reactions.
Dependent reactions. Yes, but so according to the choices, which one will you go with? C is the correct one.
I'll go with the unusual and uncommon.
Yeah. I would also go with choice C. So number 111, a phenomenon. So let's go back to Divya is saying C, example drug-related rash with eosinophilia and systemic symptoms. So number 111, thank you, Divya. A phenomenon in which the drug may not be beneficial or may do harm is known as a phenomenon in which a drug may not be beneficial or may do harm is known as, however, addition, idiosyncratic reaction, reduction, and contraindication. Yeah. I'll go with D, contraindication. I don't know what's the rest of any one of you. So someone is saying if it's choice B. Choice B of saying for idiosyncratic reaction, you define it, it's a reaction that usually uncommon or unusual. For choice for number 11, it's talking about a phenomenon in which a drug may not be beneficial, or that is that one that is harmful. So
But I
is
think
anyone also sorry?
contraindication do have some harm or benefits.
You're saying that contraindication, some of them are beneficial.
Some of them they have harm, like yeah.
Oh yeah. Yeah, so I'll go with D. So 112, the loading dose of a drug allows choice A, rapid attainment of the desired steady state levels. Choice B, maintenance of plasma levels above the therapeutic window. Choice C, less frequent dosing of a drug. Choice D is avoidance of toxic reactions. So I'll go with A, a rapid attainment of the desired steady state levels. For choice B, that is the maintenance dose. Yeah. Anyone with a different opinion for 112? So 113, which of the following is the recommended route of administration for a drug with a short half-life? So we have rectal, intramuscular, IV, intraarterial. A drug that is administered, which route of administration that is used, or the preferred one for a drug that usually has a short half-life. So I'll go with also IV, as Dr. Leting is saying. An example is those radioactive materials that are usually administered, especially for imaging. They're usually administered via IV, and you know that radioactive components usually have a very short half-life. Most of them. So 114, which of the following is associated with the least? Divya is adding something on that number 112. She's saying that intramuscular drugs have a longer half-life. So yeah, that one is eliminated. So 114, which of the following is associated with the least risk of drug toxicity? So you have old age, reduced renal function, sensitization, and dose individualization. Which of the following is associated with the least risk of drug toxicity?
I think D. I think D.
D.
Yeah, because once we can, for example, if a drug, we say 1 mg per kg, of a person, it means then we'll be giving exact doses or individualized doses to each person, therefore reducing the risk of toxicity. In terms of old age, we know old age increases drug toxicity, especially because your liver and your kidneys are having issues, so it's harder to eliminate the drug, and therefore the drug is present for longer, and there's a risk of drug toxicity. Reduced renal function, reduced elimination, so increased amounts, and then sensitization. If cells are extremely sensitized to the drugs, they can have a negative effect. But I don't know. Maybe someone can shed a bit more light.
Yeah, I also agree with that. The dose is usually individualized in terms of their needs, or as a category, or use their weight, BSA. So when you use that, you'll reduce the toxicity. I'll also go with that. Let me see the chat box. Yeah, Divya is saying also choice D. So number 115. So all of the following are produced by use of DNA recombinant technology except. So we have human insulin, we have EPO, and human growth hormone, and penicillin. So you know that penicillin is derived from a fungus, penicillium, yeah, the fungi penicillium. So that one is choice D. Yeah. Which of the following drugs does not produce tachyphylaxis? So we have, okay, there's a request from someone who flies along the walls using cobwebs. He's saying that can we do a quick overview of biotech, example of vectors, purification, etc. Anyone who was who would want to take us through the vectors, plasmids, the general biotech? Dr. Brenda Mutwiri, are you willing? Mutwiri is saying she's preparing something for biotechnology. We are waiting for you, Mutwiri. Say anything about biotechnology like vectors, plasmid. Someone has promised she's going to take us through. So we continue the next session, then we'll go back to that. So, Mr. Cobweb, are you okay with that? Yeah, so we'll go in with 116, then we'll get back to biotech. So which of the following drugs does not produce tachyphylaxis? We have ephedrine, amphetamine, Dr. Cobweb, amphetamine, theramine, and pilocarpine. So on that note, Spiderman, you can tell us the answer for 116.
I think it's pilocarpine.
Do you think, Ama, you know that's the answer? Be confident, yes. Dr. Cobweb.
Just my opinion.
Sorry, I think hii swali ilikuwa na majibu yenye ilikuwa inachanganya watu na Dr. Sam.
Because I think ChatGPT was saying because I was saying that although pilocarpine might not produce it's not that expensive compared to the other drugs. There is some degree of desensitization of chronic.
So you think sorry? Willie, are you saying something? Nighting, so you think the answer is theramine?
Yeah.
Yeah. Anyone else? Anyone else who think the answer is
my thoughts were on this. All A, choice B, choice C, they all kind of have some adrenergic activity. Like if you are just given those choices alone and you are told choose the odd one out, it will be pilocarpine. It's the only one there with a parasympathetic activity. All the other ones have some degree of sympathetic activity. And with drugs that have some degree of sympathetic activity, they generally, as a general rule, there's this development of tachyphylaxis. Hence my opinion as D, just based on that. But let me see. I don't know if Dr. Karimi is around. I know she's a honorary clinical
Aguru.
pharmacist.
Dr. Karimi?
I would also go with pilocarpine, reasons being when, as Dr. Summers or Dr. Gaz Munan has already said, looking and eliminating out when you look like something like tyramine, usually have like hypertension crisis because of things like tyramine, because of excessive production of vasoconstrictors. And so there's a high chance or possibility of them giving us tachyphylaxis other than pilocarpine. So I would still go with D as the answer.
Dr. Chai, are you convinced? I may want to go and do more research.
Let's continue. You can't convince Chai.
And so Chai, sorry about that. I'll take it for the group. So the part of the drug responsible for the activity of the drug receptor complex is called, that one is pharmacophore. So what is isosphere? And someone else also should look maybe for structure for isosphere. Anyone?
So there, it's two or more chemical compounds or ions that have similar structure and charge distribution, leading to similar chemical properties.
I've also seen somewhere they're saying isospheres are atoms, molecules, or ions of similar size containing the same number of atoms and valence electrons. For structure 4, anyone who has gotten it? So Spider-Man is saying, perhaps, while we are on this, we can do a brief overview of drug discovery, hit to lead, what happens in different phases of the clinical trials from stage 1 or phase 1, 2, 3, 4. Yeah, I'm so proud of you, Spider-Man. You have used the word perhaps for the first time. Haya, watu wenifanya na mnyendo bana. Phase 1, phase 2, the clinical trials. Anyone who is willing to take us through that? Perhaps. Brenda Mutwiri, uko na deni yetu. Are you willing to take us through that? Dr. Brenda. Aya, so there's something that has been sent in the chat box. So we have from phase 0 to phase 3. So I'll read it. So in phase 0, also, sorry. Yeah. So also known as the exploratory or the preface. This is where this phase involves a very small number of participants and is primarily focused on assessing the drug's pharmacokinetics and pharmacodynamics. So the phase 0 trials are often exploratory and may not involve any therapeutic doses. So for phase 1, in this phase, a small group of healthy volunteers or patients is given the experimental treatment for the first time in order to evaluate its safety, the dosage, and the potential side effects. So the main goal of this phase is to determine the maximum tolerated dose. So phase 1, the main goal is to determine the maximum tolerated dose. So for phase 2, in this phase now you go to a larger group of patients or volunteers that have the condition or the disease, and the intervention is intended to treat. So we have patients or the volunteers that are big. The group is a bit big, and the volunteers, they have that disease or condition. So this focus is on further assessing the safety and gathering preliminary data on efficacy. These trials is it so they're designed to confirm the efficacy and monitor the side effects. So phase 4, these trials are conducted on a much larger scale. So as you move from phase 0 to the last phase, you increase the number of the patients. So for phase 3, the trials are conducted on a much larger scale and involve a broader patient population. They are designed to confirm the efficacy and monitor the side effects in a more diverse patient group. So phase 3 trials are essential for regulatory approvals by the agencies like the FDA or the European Medicines Agency. So for phase 4, also known as post-marketing surveillance. So these trials occur after regulatory approval. So they monitor the treatments, long-term safety and effectiveness in a larger patient population. So phase 4, usually the trials help to identify the less common side effects and further evaluate the interventions real-world performance. So yeah, they're also saying that this information has been sent also in the WhatsApp group.
Maybe to add something little on the same, what we've been doing on phase 0 to phase 4, this is more than after when the drug is already on clinical trial. But before we reach to clinical trial, you usually have the pre-discovery time, whereby you getting a drug, most of the time you like there's this target and this drug can work on this target, meaning something like a receptor or an enzyme or such. So that will be pre-discovery. It's like there is an initiative that this drug can work on a certain receptor. So after that, there is this preclinical safety and toxicity testing, which is more on like animal trial. So before we come to the clinical trial, phase 1, phase 2, phase 3, and phase 4, phase 0 to 4, is first that set of preclinical trial and animal testing. Thank you. And also for phase 1, it's usually done on healthy individuals. Yeah, this drug is being given to the healthy individuals, not the sick ones. Thank you.
Thank you so much, Dr. Karimi, for that. Yeah. We have not gotten any information from the lead, heat to lead compounds, and that's
Wait,
the
Stanley,
overview.
let me ask,
Sorry?
is the animal testing in phase 0, or is that a phase, there's a phase before phase 0 where they do animal testing? I was not clear on that.
Sorry, Comfort,
So,
you're actually.
Comfort, I think it's before. You see, when you're
Mm.
doing research and development, like she said, you do step 1 is drug discovery and development. Then after that, you do preclinical research where you do in vitro and in vivo. So you'll do your studies. That's where you do the animal studies. Then now after that is approved, then you can now do the clinical ones. So it's before phase 0.
Okay, thank you.
Welcome, Dr. Shafi. Dr. Shafi has been texting me that said she wants to lead also. So, Dr. Shafi, the floor is yours.
Okay, my internet is very unstable. If I break or anything, you let me know. And then question 118, structure activity relationship I used for the designing of all the following except pharmacological, me too, drugs, antagonist.
Someone has said D, but I'm wondering for D, wouldn't we use the physiological agonist, then, like the structure activity relationships, to then design drugs which are similar? Maybe, for example, levodopa and carbidopa, how they are similar to dopamine.
But then will that be physiological or structural? If you basically trying to make a similar molecule, is it physiological or structural? I don't know.
I think because if you look at like the how dopamine looks like, and then you look at how levodopa and carbidopa look like, don't they have similar structures, sort of, other than the added, I think it's a hydroxyl or what? Yeah, but and even levodopa in itself, doesn't it have a similar structure to dopamine?
Oh, sorry, guys. Sorry for that. I was locked out. But can we continue from here tomorrow? It's already 10. Amma, what do you guys think?
We can finish that question 118, then we stop.
Okay, are you guys all in agreement? Yes, physiological agonist. Explanation. Continue. Who was that?
No, I'm saying I think it's congeners.
You think it is?
Saying C, congeners.
Oh, congeners.
Yeah. I think I also agree with her. Maybe we can say I think
Do you guys have any explanation why you chose C? Congeners are a group of chemical compounds that are structurally similar and have similar properties. Okay.
But then if they have similar properties and configuration, so you would need the structure activity relationship to make like those kind of molecules.
Yeah, to differentiate.
Okay, why should you make the same compound with same structures and same chemical properties?
for example, like maybe like adrenaline. We also give adrenaline as a drug. So sometimes even insulin itself. So just generally, we can copy the exact same drug because it can, because the person might have a deficiency. But just, I don't know. Personally, I was saying, I was thinking, I was avoiding D because I was thinking we'll use the structure activity relationships of physiological agonists to then form our own, agonists. To then form our drugs, like that structure activity relationship, we can use that to form the drugs. That makes sense.
Is Dr. Sam here? What do you think?
Kidogo sikuwapata vizuri.
What do you think of this question, 118?
Okay, I think I'd actually go with as the answer because, yeah, like if we take, for example, the antagonist, that is actually true. For example, I think we used histamine when you're trying to produce antihistamine drugs. We're basically just basing them on the structure of histamine and then making them more bulky. For congeners, okay, I'm not so sure about C, but for D, I think D and B, they actually go together.
Sam, what's the meaning of for choice A, pharmacological me too drugs? Like what's
Okay. Okay, I haven't come across that before, but what I think basically they're referring to drugs which work maybe on the same okay, not exactly mechanism of action, but on the same receptor, I think. Okay, I'm not sure.
Yeah.
I'm not sure, but I think on
Yeah,
the
'cause
same receptor.
yeah, I was also thinking the same, like the way we had one of the first beta blockers being propranolol, and then based on its structure, we produce stuff that acts like propranolol, maybe only in a better way, stuff like that.
Yeah, I
Yeah.
can read out. Can I read it out?
Oh, so I think
Please.
Yeah, the term Me Too drug or follow-on drug refers to a medication that is similar to pre-existing drug, usually by making minor modifications to the prototype, reflected in slight changes in the profile of side effects or activity, and used to treat conditions for which drug already exists. So you are right.
Then if that's the case, the answer is C.
Oh, C, not D.
Because for
You think
D,
D?
physiological agonists, they just basically produce the same effects, but then they interact with the same receptors, with different receptors. If they're interacting with different receptors, they definitely have different structures.
Yeah, see, that means that that actually the molecules won't be based on the structure activity relationship because the effect is the same. But what do you guys think? Because if the effects are the same but the receptors are different, I don't think the structures need to be similar. So like there isn't any structure activity relationship
Yeah.
that you're following. Because if you compared A and D, I think they're actually kind of antagonizing each other. I don't know what you guys think, but
Yeah, I think based on the definition that Seraphine has given, what we know that physiological, they will act on different receptors. One will act on the histamine, another one will act on the adrenergic receptor. So that is in no way based on the structure.
Yeah.
So we are saying that, but see, the answer there is D.
Yeah, I also agree with D.
And who can, what are example of congeners, like two stuff that you can say number one and number two, or drug A and drug B, they are congeners also, just to help us understand perhaps, because we've seen pharmacological Me Too drugs is you had an earlier one and then you updated it, or you produce more drugs from the initial compound you had. What of congeners or cogeners? I don't know.
Okay, for the congeners, I think something we used to do in bioinformatics. There's this database we used to use, ilikuwa Swiss similarity. So basically, you'd find that to just pick any drug, say aspirin, and then there's some, we used to call them canonical smiles. If you were to paste the canonical, basically, the canonical smiles just tell you about the structure, basically the compound itself, the number of carbon atoms, the number of atoms that it has, if it's carbon, oxygen, etc. So basically, it's like a barcode for a given molecule. So if you take it and then you paste it over there, it will actually give you similar compounds, which are actually not drugs in the market, but they have a slightly different addition, or how will I say it? Yeah, like they just similar. Okay, I'll just try and find an example. I'll send them. I think that is what they refer to as congeners, I think. Send that after example, I'll share it in the group.
Thanks. Shafi Stanley, back to you.
We are done. Good night. For real, I'm tired. Unless you want to take over.